So, as we said before, on 4-1, tomorrow on your test, we're going to have one question on the divisibility rules. There's 16 total questions. There'll be more than 16 points. One of those 16 comes from lesson 4-1 on the divisibility rules. And I told you that it's going to be written very similar to problem number 1 and problem number 3. All right? So, problem number 1, we want to know 384. And now we want to know, if we look at the directions, it says is 2, 3, 4, 5, 6, 9, or 10. Will any one of those numbers go into it? Yes. So we should know the divisibility rules for 2, 3, 4, 5, 6, 9, and 10. So let's start off. Let's list which ones work. Let's start off with 2. Does 2 go into 384? Yes. Does 2 go into 384? Yes. How do we know that it goes into that 2 goes into it? Go ahead, Ellie, when everyone's quiet. It's an even number. If the last number is 0, 2, 4, 6, or 8, guess what? It's even. So right now, I just list 2 is one of them that it goes into. How about 3? How do we know if a number is divisible by 3? Yep, Taylor?
Add all the numbers together.
Sure, we add up all the digits. So look here. I'm going to do 3 plus 8 plus 4. That's adding up all the digits. Okay? 3 plus 8 is 11. 11 plus 4 is 15. Does 3 go into 15? So guess what? We know that's that 3 will go into it. We'll get to that in a second, but yes, that's correct. I'm going to ask you why in a second. Okay? Does 4 go into it? How do we know 4 goes into it? Nope, not because 2 goes into it. Okay? The last 2 digits have to be divisible by 4. Will 4 go into 84? It will. It goes in there 21 times. Okay? So 4 is going to work. Does 5 work? How do we know 5 does not work? Go ahead. It has to end in 0 or 5 doesn't do it, so we don't include 5 in our group. Okay? How about 6? Yes? Everybody hear that? We know 6 works if both 2 and 3 work. Okay? All right? Now, does 9 work? No. 9's rule is just like 3's rule. We take the sum of the digits, and if that sum is divisible by 9, does 9 go into 15 evenly? Or without a decimal? Nope. Okay, so we know 9 doesn't work. How about 10? No, we're down right there. How many kids got number 1 right? How many kids have 2, 3, 4, and 6? If you didn't, you need to ask questions now. Are there any questions? 3. What does number 3 say? 724. Same thing. Does 2 go into it? Yep, 2 goes in, it's even. Does 3 go into it? Well, let's see. 7 plus 2 is 9, plus 4 more is a grand total of 13. 3 does not go into 13, right? Okay, so we don't include 3. How about 4? How do we know 4 goes in? Last 2 digits, 24. 4 goes into 24. Does 5 go into it? No. 6 doesn't work because we need both 2 and 3 to work. How about 9? How about 10? No, so our answer for 3 is just 2 and 4. Okay? Now, kids, you're going to have to do that exactly tomorrow. You'll have one question. Any further questions on divisibility? We good to go? Okay, then I'd like you to work on problems 5 and 7 right now. 5 and 7. Okay? This will be lesson 4-2. I need everybody right now in their tracking sheets. Right now, everyone should have out their tracking sheet. And before we move on to these questions from 4-2, we need to put in a ranking for 4-1. Now, if you don't have your tracking sheet with you, on this exact same sheet that you're working on, you can say, list those number 1 and 3. You can say that's from 4-1, and I need you to put in your final ranking. Where are you at right now? Can you teach it to somebody else? That's a 4. Okay? A 3 means, you know what, I can get it most of the time, but I slip up on something. Okay? Maybe you don't quite know the divisibility rules of 9. Shh, that doesn't work. Okay? So for 4-1, I need everyone to put in their own ranking right now. And maybe even on your tracking sheet, you might even have to put that there's going to be one question from 4-1 tomorrow. Okay? Everybody have that down. Okay, the last thing I'm going to, I don't know why there's any talking. Thank you, I appreciate that. All right, 4-2. 4-2 has 2 main parts that we need to understand. 1, you have to list out the factors of a number. And 2, we have to determine whether a number is prime or composite. So let's just review. Factors are the numbers that you can multiply to get to 98. Okay? Now, the most common factors that kids miss when we list out factors, and I still hear talking, shouldn't hear it, is really the 2 easiest ones. Here's the 2 easiest factors of 98. Eyes here. 1 times 98 is 98. Okay? And everybody can see right now, I'm going to use this method where I'm making my factor rainbow. Okay? So there's factors. Okay? Now, the second piece that we have to talk about is whether the number is prime or composite. And we can tell if a number is prime or composite by understanding what is a prime number, what's a composite number. A prime number means that we only have one set of factors. The only way to multiply to get to 98, if 98 is prime, the only way to get there is 1 times 98. I know for a fact that 98 is not prime. I know for a fact that it's composite. So I'm going to put C down there for composite. Who can tell me? How do I know for sure that it's composite? Did everybody hear that? 2 can go into it because it's an even number. We're still using divisibility rules right now. So 2 times what number gives us 98? Okay? Well, if we go 2 times 50 is 100, right? Let's go 2 times 40. What's two groups of 40? 80. So we know it's going to be in the 40s. Okay? Okay? And if we take 80 and subtract it from 90 or 98 and subtract 80, we have a grand total 18. How many times will 2 go into 18? 9 times. 9 times. So I bet 49 times 2. Let's try this. 49 times 2, 18, 1 extra 10, 8. It gives me 90. Are we good to go? All right, let's see if will 3 go into 98?
Yes. No.
Use your divisibility rules. 9 plus 8 is 17. 3 won't go in there. Will 4 go into 98? 4 won't go into 98. 4 will go into 88. And then if we add 4 more, 4 will go into 92. 4 will go into 96, and 4 will go into 100. So 4 will not go into 98. Okay? Hey, you can work on that little card later. Save it for art class. Okay? All right? So we're on, we skip 3, we skip 4. Does 5 go into it? Will 6 go into it? Okay. Will 7 go into it? You know what? 7's one of those tricky ones that we have to just go in and try and divide. 98 divided by 7. We have one group here, and we have 28 left. Does 7 go into 28? Yeah. Kids, we have to try those prime numbers, otherwise we're going to miss a list. And 4 times 7 is 28. Guess what? That means 7 and 14 are factors of 98. Now we need to keep going up. Okay, let's see if 9 works. Is 9 going to work? No? What about 8? You know what? If 4 doesn't work, I know 8's not going to work. Okay? So that's a simple way. That was a good question. What about 8? Well, think about, here, I'll start listing. Here are the factors, or multiples of 4. 4, 2 groups of 4 is 8, and that's the first group. 3 groups of 4 is 12. 8 doesn't go into 12. 4 groups of 4 is 16. So guess what? If we know that 4 will go into it, every other multiple of 4 will go into 8. 8's not going to work if 4 doesn't work. Okay, so you can skip that one. All right? Does 9 work?
No.
Does 10 work?
No.
No. 11, we can't do it. 11 times 9 is 99. Okay? 12 doesn't work. 13. We're done right now. We've made all of our, we've covered all of our numbers. Once I get to this number right here, this middle number of 14, that's why I went to 11, 12, 13. None of those numbers work. We're good to go. Okay? Those are the factors, and it is composite because it has more than one set of factors. Okay? Everybody okay on that? How many kids got 98 right? If you didn't get it right, I'm guessing it's because you missed 7 and you missed 14. Is that right? No? I said if you didn't get it right, it's because you probably missed 7 times 14. Okay? All right, number 7 is 45. All right, 1 and 45 will work, right? We got to remember the first one right away. Will 2 go into it? No, it's not even. Will 3 go into it? 3 does. 3 times 3 groups of 15 is 45. Will 4 go into it? No, 4 will go into 44. 4 times 11 is 44. All right, will 5 go into it?
Yes.
Yeah, because it ends in 5. It better work. And 5 times what? 9. Now, does everybody see, now that I did 5 and 9, my only other possible options are 6, 7, and 8. We already know 6 isn't going to work because it's not even. 7 doesn't go into 45. And 8, we just talked about that. If 4 doesn't work, guess what? 8's not going to work. So we are done right there. Now, is it a prime or composite number? It's a composite number because it has 1, 2, 3 pairs. I'm so glad your parents can hear what you're like every day in class. Especially on a review day, you'd think you'd really pay attention. One would think. I don't know. And you know what? The evidence is right here. Because I'm putting it right on my, I can tell. Then before we move on, who can give me? Let's see if we can list 4 numbers that we know for a fact are prime. Okay? 4 numbers that we know for a fact are prime. So some prime numbers. Let's list 4 of them. Who can give me 1? Go ahead. No, I'm sorry. Here's an interesting one. 1 is neither prime nor composite. Okay? The only way to get 1 is 1 times 1. It doesn't even have a pair. So 1 is not composite. It's not prime either. Good try on that. I'm glad you brought that up. Go ahead. 2. The only way to get 2 is 2 times 1. So 2 is a prime number. In fact, 2 is the only even prime number. It's the only one. Okay? Brennan, 3 is a prime number. Okay, then next one has to be a double-digit number. A double-digit number that's prime. Okay, go ahead. 11's a perfect one. 11. The only way to get 11, the only two factors 11 has is 1 times 11. We're done. We get it. 4-2. This is still 4-2 continued prime factorization. When we do prime factorization, we have to we can do one of two things. We can list all the factors, or we can break it down by prime numbers that are factors, or we can create our factor tree. How many kids use factor trees? Every time. Okay, it looks like everyone's using that, although Emma's, do we use factor trees, or what method do we use? Then your hand should be in the air. All right, factor trees. The easiest way to do this is to use prime numbers right off the bat. So I know 2 is a prime number, is that right? And I know 2 is going to go in here because it's even. How many times will 2 go into 64? 32 times. Now I circle my prime numbers. Now I'm dealing with 32. Okay? I'm no longer dealing with 64. I'm just dealing with this 32. It's even, isn't it? So let's take out the 2's and say 2 times 16. Now I'm done with 32 and now I'm dealing with 16. And again, it's even, right? So let's take out the 2's. 2 and 8. And 8. Now we're dealing with 8. Is 8 even?
Yes.
TJ, eyes on the board, please. 2 and 4. Now I'm going to deal with 4 and say 2 and 2. Now, kids, tomorrow, it's going to be a 4-point question on prime factorization. And I'm going to tell you right now, there's going to be kids that do this right here and say, Mr. Martin, I did prime factorization. I'm done. Shh. But look you got to keep this in mind. You need to tell me the prime factors. Factors means we need to multiply. So we need to go 2, that's this one, times 2, that's that one, times 2, that one, times 2, that one, times 2, that one, times 2, that one. Got them all covered, right? So I have a grand total of 2 to the 6th power. Okay, next one goes a lot quicker. 49 is not a prime number. 1 times 49, but it does have a factor. Both of them are prime. 7 times 7 is 49. The prime factorization is just 7 times 7. Whoops, that's a bad 7. And another way to say 7 times 7 is 7 what? 7 to the 2nd power, or 7 squared. Any questions on that? Okay. Yes. So we'll do 2 up here on 4-3. Greatest common factor. We'll do number 13 and number 15. And we're going to do them together. You need to do it right with me because we need to get going. Greatest common factor between 24 and 108. One way to do it, and this is the way most kids are using, is by listing out all the factors, using factor rainbows. Okay? So let's list them for 24. 1 and 24. 2 and 12. 3 and 8. 4 and 6. Okay? Got them all. Now let's do 108. 108. We know it's even, so it'd be 2 and 54. Excuse me. Guess what? I know that 3 goes into it. 3 and, let's see, that's going to be 16. 4 will go into it, right?
Yeah.
Okay. 4 will go into it, I believe, 27 times. 5 won't go into it. 6 has to go into it because, all right, so let's do 108 divided by 6. And 6 times, what did I do wrong? 2, 6 times 8 is 48. Boy, so did I. I thought for a second I messed up as well. 6 and 18. 7's not going to go in there. Okay. 8. We could check to see if 8 goes in there. 8 times, well, we'll just do it. 108. It's not. Look at this. Does 8 go into 28? No. 8 times 3 is 24. 8 times 4 is 32, so that's not going to work. 8's not going to work. 9 does. Oh, is 9 going to work? We have one more. 9 and. No, it's actually 13. No, 12. 9 and 12. And then we're done. Okay? Now we can find the greatest common factor that they have. Yeah. Oh, I'm sorry. It's not 16. It's not 16. Did I say 3 times 27? All right, well, let's see. 108 times. Oh, it's 36. It's 36. I almost did the same mistake twice. How about 36? Okay, now we can go through and find our greatest common factors that they're all listed. 1, 2, 3s, and 4s all match up. 6 matches up. 12 matches up. So our greatest common factor is 12. Okay, now we can use prime factorization to do it as well. But just from looking at your work, most kids